There are lots of different interfaces for accessibility that allow people with disabilities to use a computer or another device such as a smartphone or tablet, even if they can't use the standard keyboard or mouse. And to strengthen the understanding of how well do users do with different access interfaces, we built this AT Node for Access website. So I'm just going to give you a quick demo of the main search path on this. This is a website that includes data on text entry rate, basically typing speed data from studies published since 1986. And all the data in here are from research studies that involved computer users with disabilities. What I'm going to show you here is a quick way to do a user profile search. And we would click here on this, and it's basically a combination of what diagnosis are you interested in and what interface are you interested in. So I'll just pick, for example, cervical spinal cord injury, and we'll pick physical keyboard. And so in just a couple clicks, we've retrieved all the data in the database that has both individuals who've had a cervical spinal cord injury and who are using a physical keyboard in some way as part of their involvement in the study. So it gives you a little description. There's 29 cases in the data set. We see a histogram here of the distribution. So in other words, how many people typed at a text entry rate between down here 2 and 4 words a minute, one person. And actually, if we hover over this cell, this represents the data for that one person, and it shows us the study it was from, in this case, Kester 2004, and the text entry rate for that person, 3.7. So each of these actually represents a case in the data set. We have kind of a sweet spot here. Median is about, looks to be about 10 to 12 words per minute. And we have a few people here with cervical spinal cord injury typing above 30 words per minute. So we might say, oh, I wonder what they're all from Kester 2007. Can I look at that study? Yes, you can. You could click on that box and it'll open up an abstract, the abstract for the study, and give you a little pointer to the citation and give you a little better understanding of what the study is all about. And if you want, you can look at the data that go into those graphs. So this shows you all 29 cases that were reported by their age, their gender, diagnosis, and the body site, and also whether they use the strategy such as word prediction to type. And you can download these data as well to get them into a spreadsheet for yourself. I'll show you briefly the advanced search in which you can, we'll add, let's say we want to look at speech recognition and physical keyboard. So this just gives you a fine-grained way of choosing a combination of any of the diagnoses, interfaces, and body sites. We can pick all. So here to the search we just did, we're just adding a speech recognition option. And we get 39 cases this time. We still have a histogram. We don't know which of these cases was physical keyboard and which was speech recognition, but it kind of gives you the profile here of how well people did. But if you do want to know the difference between speech recognition and physical keyboard, this is your graph here, the text entry rate by interface. On average, we're getting about 15 words per minute with speech recognition. On average with physical keyboard, about 12.2. So that does have an advantage, although 15 words per minute in the literature at least is maybe not quite as fast as you would think people go with speech recognition. So that's the basic idea of AT Node. It's kind of a neat entree into the literature and can inform decision making and give you some rough expectations of what to expect with a given diagnosis and a given interface.